नमस्कार विद्यार्थी मित्रो, मी आहे संदीप वाघ आणि मी आपलं स्वागत करतो आमच्या नवीन एज्युकेशनल यूट्यूब चॅनलमध्ये, ज्याचं नाव आहे विकासदीप अकॅडमी. या चॅनल अंतर्गत विविध विषयांवरील क्रिटिकल कन्सेप्ट्स आणि डाऊट्स आम्ही साध्या सरळ सोप्या भाषेत समजावून सांगत असतो. आजचा आपला टॉपिक आहे न्यूटन्स थर्ड लॉ ऑफ मोशन. The statement of the law is that every action force has an equal and opposite reaction force which acts simultaneously. For example, walking and swimming. म्हणजे काय तर जर आपण एखाद्या बॉडीवर ॲक्शन फोर्स लावायचा प्रयत्न केला तर ती बॉडी आपल्यावर रिॲक्शन फोर्स लावते आणि यालाच म्हणतात न्यूटन्स थर्ड लॉ ऑफ मोशन. फॉर एक्झाम्पल, वॉकिंग. सो व्हेन वी आर वॉकिंग वी पुश द अर्थ बॅक अँड अर्थ पुशेस अस फॉरवर्ड. सिमिलरली, while swimming we push the water back and the water pushes us forward. Now the law of conservation of momentum. What is the momentum? I have explained in the previous lecture. I will give link into the description. Please go there and see what is the momentum. So law of conservation of momentum. Suppose there are two objects, object A and object B, and the initial momentum of an object A is m1 u1 and the initial momentum of an object B is exerted by, when these two objects collide, the force exerted by f1 is by object A is f1 and the force exerted by object B is f2. These two forces are equal in magnitude and opposite in direction, and because of that the final momentum of an object A is m1 v1 and the final momentum of an object B is m2 v2. According to Newton's third law of motion, it is denoted by the force exerted by A is F1 and the force exerted by B is minus F2. This minus sign indicates that the force is in opposite direction to that of the F1. Now, according to Newton's second law of motion, we have derived that F is equals to ma. F is equals to ma. Putting this value in this equation, we get m1 a1 equals to minus m2 a2. Again, this acceleration is nothing but the rate of change of velocity, v divided by t, v minus u divided by t. So putting this value of a into this equation, we get m1 inside the bracket v1 minus u1 divided by t, and it is equal to minus m2 inside the bracket v2 minus u2 divided by t. Now this t will get cancel out and the remaining terms are m1 v1 minus m1 u1 is equals to minus m2 v2 plus m2 u2. Now rearranging these terms, we will get that m1 v1 plus m2 v2 is equals to m1 u1 plus m2 u2. Now if we observe these equations, we get that terms, the magnitude of initial final momentum of an object is equal to the magnitude of initial momentum of an object. So when the two objects collide, the momentum before collision is equal to the momentum after collision. That is called the law of conservation of momentum. Now I am having one question to you students, that in the first lecture we have seen that when there is two forces are opposite in direction and having equal magnitude, the object does not move to any side. But in the Newton's third law of motion, we see that we are applying force on the body, and the body applies reaction force to us, and we move from our place. So how it is possible that in one statement it is body is stationary, and in the second case the body is moving although the forces are equal in magnitude and opposite in direction? That is, this statement is forces are equal in magnitude and opposite in direction, then also the body is moving. And whereas in the first chapter we seen that when the force is acting on a body, the body does not move to any side.